Well, hello again. This is the third little video about verifying trig identities, and I'm going to take another example out of your book for your reference. This is example number 6 on page 532. And if you watched the previous video, I made the comment that very often in simplifying or verifying these trig identities, we want to take the more complicated side and simplify it down so that it looks like the simpler side. Well, geez, in this identity here, you'd have a hard time figuring out which one is the simpler or the more complicated side. So we're going to use a little bit different technique here. We're going to work with both sides of this identity and change them both into something completely different, but it'll be equal on the left and the right-hand side. And so I'm going to use the notation in the book. Oh, gee, there's the lunch bell. I'm going to use the notation in the book calling the left-hand side LHS. And the right-hand side, RHS. So here's our left-hand side here, 1 plus cosine over cosine. And there's an interesting little thing that we can do with this fraction right here. I can actually split this up into two fractions with the same denominator, cosine theta. All right? Now look, what would the numerator of these fractions be? Well, it's just like the rule where you add fractions together with common denominators just by combining the numerators together. We're basically using that rule in reverse. So we can split this up into 1 over cosine plus cosine over cosine, which, as you can see, is pretty nice, simplifying down to secant theta plus 1. Okay, now let's take a look at the right-hand side, which, if we look back here, was tan squared over secant theta minus 1. So let's set up that right here. This is the right-hand side now. All right, tan squared over secant theta minus 1. Now let's take a look at this. Tan squared theta is the same thing as saying secant squared theta. Whoops, let me redo that. Secant squared theta minus 1. That's from our basic Pythagorean identity, 1 plus tangent squared equals secant squared. All right? And so that equation right here, manipulated around, gives us this substitution that we can use. Tangent squared equals secant squared minus 1. And I have secant theta on the bottom. Now, I'm going to point out something about this secant squared minus 1. It is the same thing as having one perfect square minus another perfect square, because 1 is actually a perfect square. There's the bell. So secant squared minus 1 is in the same form here as a squared minus b squared. And if you factor that, you remember your difference of squares factoring, that equals a plus b times a minus b. Pretty tricky here, and we're going to say that then that secant squared minus 1 is equal to secant theta plus 1 times secant theta minus 1. And look at that. On the bottom, we have secant theta minus 1, which we can now cancel out as common factors. And so this right-hand side ends up being just secant theta plus 1. Sorry, secant theta plus 1. And that's the same thing that we had to begin with. Same thing as our left-hand side over there, secant theta plus 1. So we've proven that identity by making both sides equal the same thing.